Okay, example 2, basically it's the same problem as example 1 except there's a plus sign between the two fractions. So what I want to do is I want to simplify this expression and simplify this expression separately, and then once I got both of them simplified I want to add them together if possible. I will say this, the problems are structured in such a way they will be possible to be added together. Common denominators are necessary, but the radicals will be the same radical. At this point they aren't. Okay? 2/5 and 5/2 obviously aren't the same number, so adding them together at this point is not an option. If I take a look at the blue one, what I like to do on these problems is this. I'm going to do the square root of 2 over the square root of 5, and I'm going to leave myself a gap, and then I'm going to put the square root of 5 over the square root of 2. Okay? I'm leaving a gap with this intention of I've got to multiply top and bottom by the same thing. I'm leaving some space for that to happen. If you can anticipate parts in a math problem where you're going to have to put some stuff in, leaving some space, it allows for a little bit more organization of your work and it makes the problems a little bit simpler to deal with. For this one, the problem is the square root of 5 in the denominator. And to fix that issue, I'm going to multiply top and bottom by the square root of 5. Square root of 5 times the square root of 5 makes the square root of 25, which is 5. So again, fixing a square root is just a matter of multiplying by the exact same object. With this red one, the problem is the square root of 2 in the denominator. I'm going to multiply top and bottom by the square root of 2 to fix that. This multiplication has no bearing on this one. This multiplication has no bearing on that one. The plus sign separates the terms. The blue term is going to be fixed by the square root of 5. The red term is going to be fixed by the square root of 2. So when I do the blue term, on top the square root of 2 and the square root of 5 makes the square root of 10 on top. On the bottom, square root of 5 times itself makes 5 on the bottom. Again, do not be tempted to try and reduce. This is inside, that's outside. We cannot get those numbers interacting with each other. The second fraction, on top we get the square root of 5 times the square root of 2, which is the square root of 10. On the bottom, square root of 2 times the square root of 2 makes 2. Once again, reduction is not possible because 10 is inside the radical, 2 is outside the radical. And at this point, the question of can I add these together or not is based on these square roots themselves. You can see both square roots are the same, so adding them together is legal. I do need to assume there to be a 1 there and a 1 there. What I'm trying to do basically is add together the 1/5 and the 1/2. The square root of 10 is just going to come along for the ride. Hopefully we can all see the common denominator here is 10, right? 5 times 2 is 10. All right. And then for each fraction, I need to fix the top the same way I fix the bottom. So what did I multiply 5 by? So 1 times 2 makes 2 times the square root of 10. And then looking at the red one, 2 times 5, right? So 1 times 5 is going to be 5 times the square root of 10. So it's just basic adding of fractions. The square roots of 10 aren't going to do anything. They're just there. They're part of the problem, but they're not going to create any kind of issue for us. They're just kind of coming along for the ride. So to get the final answer here, I just have to add the top numbers. 2 square root of 10 plus 5 square root of 10 makes 7 square root of 10 on top. We get a 10 on the bottom, and that's our final answer. All right, once again, that is the final answer. What you can look for sometimes on these problems, again, these don't reduce and these don't reduce because we have something inside, something outside. Occasionally, that will reduce. And that is a legal reduction if you want to do that. For example, if this came out to 2 over 10, that will reduce to 1/5. Proof. 2 over 10, 1/5, right? So we have the ability to modify those outside numbers like that. But the inside number is going to stay. Once you get whatever it is here, that's what it's going to be all the way through the rest of the problem. And once again, verification by calculator to verify the same answer. Square root of 2 divided by 5. Well, now you know what button you're supposed to press at least. Let me try this again. I wish I could do that. All right. So if I type in square root of 2 divided by 5 plus the square root of 5 divided by 2 equals 2.21 whatever, and then the answer was 7 times the square root of 10 divided by 10. It's the exact same decimal approximation, which tells me that I got the right answer. So again, very easily checked, and I recommend doing that until you get to the point where you're getting right every single time. I wouldn't worry about that anymore at that point.